In this video, I'm going to show you the most commonly missed problem that we had from our recent bingo review. This one seemed to be most challenging, so I wanted to go over this with you. If you have not done the Kahoot review game, go ahead and check your remind, and you will see a link to complete that. But I'm going to go ahead and go over this one. So the question that was on the slideshow had said, when solutions of these two compounds are combined, what precipitate forms? So this is a precipitation reaction, as you might have guessed from the word precipitate. I went ahead and wrote out that part of the reaction that they already told us about. So I combined those two compounds, and then we're going to figure out what happens in that reaction, what is created. The first thing that I started by doing was I went ahead and wrote out my cations and anions so I can see how they will recombine. So for example, here's my magnesium and my iron, my cations. And then I'll write my anions in red just to remind myself that these ones are negative, or they will accept a negativity, they'll accept that electron. So how do we know the charges on those? I went ahead and included some references that you have in your reference sheet, your solubility table, your polyatomic ions, and your periodic table. You will need all of these, so remember to use your resources. So on this polyatomic ion list, I can see carbonate is CO3 2-. So there's my 2-. And sulfate, down here at the bottom, is SO4 2-. Alright, so now I know my charges on my polyatomic ions. So how do I get my charges for my cations here? Magnesium is pretty easy. It is right here on the periodic table, and that column, that second column, it likes to be 2+. Iron, on the other hand, is one of our transition metals. It's a little bit more challenging because it could potentially have a charge of 2 or 3. It just kind of depends. So how did we figure this one out? Well, we have our compound that is given in the example. We know it was made by combining the iron, plus the sulfate. And we already know that that sulfate has a 2- charge. Remember how we write our ionic compounds? We cross those charges. So the 2 would have crossed to the left-hand side. That's where we got Fe2. And something crossed from the iron side and gave us this SO4 3. So we know it had to be that number 3. So iron was 3+. We do our double replacement reaction. So our cation from the first compound will go with the anion from the second, and the cation from the second compound will go with the anion from the first. So when we recombine those, we have magnesium sulfate. Notice that this has a 2+ charge, this has a 2-, so they will cancel out. We don't need subscripts. I'm going to leave a little bit of room so we can write about our solubility, the states. Put a plus sign, and the second one would be iron, carbonate. So remember those charges crossed over? So the carbonate had a 2- charge. That goes right here with the iron. And then the 3 from the iron goes right outside of there. So we still don't know which one is the precipitate yet. We know what the reaction is creating, but we need to figure out which of these is insoluble. Remember that a precipitate will form a solid that will not be able to dissolve in that compound. So the way we look at our solubility table is we look them up based on their anion. So I'm going to start by looking up the sulfate. Here it is down here. And this table tells me that sulfate should be soluble unless it has one of these exceptions. So look and see if magnesium is on this list of exceptions, and it is not. So it is soluble, meaning it will dissolve. It is aqueous. The other one is our iron carbonate. So carbonate is on that next portion of the table, right here. Notice it says this portion of the table is insoluble, meaning it'll form a solid unless it has one of these exceptions. So look closely at those exceptions. Iron is not listed as an exception. So this is in fact insoluble. So for this question, when it asks you which solution or which precipitate will form from the combination of those two solutions, your correct answer should have been this iron carbonate.